Microscopes. Saying this word, the first thing that may come to your mind are lenses. That is, this microscope. But there is more to them. Microscopes can look like two. This kind of microscope is called acoustic microscope or scanning acoustic microscope. This one uses sound to produce images. Sounds that are waves with rarefactions and compressions. So what happens? How does it produce images with sound? But what do we need to see? So the microscope is used in research, especially in medical fields where we can see large 2D or 3D images of cells. We can determine tiny cracks or voids or even bubbles on the surface of the object. So how does it work? First, there comes a transducer. A transducer is a device that can convert electrical energy to sound energy. So the sound waves within frequency of 5 to 300 megahertz are transmitted from the transducer to the sample, which gets reflected back as a returned echo. Image is formed by the consideration of amplitude and the time taken for the wave to travel back and forth. The impedance mismatch is measured by the amplitude of the reflected wave. The wave that travels back is the reflected wave or the echo wave. The refracted wave is the one that gets absorbed. Acoustic impedance, denoted by Z, is the resistance experienced by sound waves, where Z is product of density of material into speed of wave in propagating material. If the velocity and density of sound in that medium is high, acoustic impedance is higher. More the impedance mismatch, more is the intensity.
Lower difference in impedance between object and interface results in shearing, and wave can reach into much deeper. Lower frequency results in lower resolution, but it gives high penetration, which is important for examining very tiny objects. Depth of penetration can be determined by time required for wave to reflect and velocity of sound wave in material. So we get this equation: D is equal to C into T by 2, where divided by 2 is because of one cycle of reflection. Here is an example how you can use reflection time to measure penetration depth if velocity of sound wave in particular material is known. Here are some examples of images produced by acoustic microscope. Use of acoustic microscope in pathology lab. We saw benefits of acoustic microscope, but there are some limitations too. First, it's very expensive. Second, it takes longer time to process. And third, it's very huge in size. Now, you know about acoustic microscope very well. How useful you think is it? References that we used. Thank you for your attention.